These series of videos are demonstrating how to automate economic policy through code. A link to the GitHub repository is included in the video description. In the previous video, we learned how to bootcamp ourselves into the project. In this video, we'll expand the platform into Kubernetes to support smooth scaling of constantly running services. Now, as of September 2024, 3 more services are added to the project since the last video. The first one is Redis. For now, it runs in a container. Open up the Docker directory, and here it is in the compose file. Or open the K8s directory. Here's the Kubernetes deployment manifest. The second service is the event service. Open the services directory and event. The event service first listens to Postgres for notifications. And we might as well look at how Postgres is configured to send those notifications, so open the migrations directory, schema, and the equilibrium up migration. This insert equilibrium function records when transaction requests become transactions and notifies listeners about an increase in GDP. And it's in real time. The insert equilibrium trigger fires when a transaction equilibrium time is no longer null. That means all parties involved have approved and we have a transaction. Okay, so back to the event service. Event receives the GDP notification from Postgres and then increments a GDP key in Redis. Redis is also instructed to publish the new GDP value after it's changed. Now, the third new service is the measure service. Open services and measure. For now, the measure service just subscribes to Redis and passes messages from that subscription to a WebSocket. Downstream, GraphqL sources the WebSocket in a subscription. And this is where the client gets its real-time GDP value. Okay, to summarize, the new services are Redis, Event, and Measure. And now we'll push these 3 new services to a Kubernetes instance in the cloud. Terraform has a new micro-K8s module. Navigate to Infra. The infrastructure directory was abbreviated to Infra. Then Terraform, AWS, Modules, and micro-K8s. This is the location of the module. We're not using EKS to demo 3 Kubernetes services. That's too complicated and adds an unnecessary expense. So we'll stick to micro-K8s. Let's add this module to our dev environment. Open the neighboring environments directory under AWS, dev, and main.tf. Scroll down to the Enable micro-K8s variable assignment and switch it to true. Now open a terminal, cd into Infra, Terraform, AWS, Environments, and Dev. Add the module with Terraform init. Now Terraform apply. Type yes and enter. Okay, 7 resources were added to the cloud dev environment. Now let's deploy the 3 new services to micro-K8s running in the new EC2 instance. Open another shell, and from project root, cd into the K8s directory, and make deploy with env assigned to dev. Fire away. Kubernetes deployments and services are created. Now all we have to do for a simple test of these new Kubernetes services is create a WebSocket with the measure service, complete a transaction, and wait for a GDP value to appear. So let's query the public IP of the new EC2. And yes, we're using a public IP because adding privately subnetted hosts with netted IPs behind a load balancer is getting carried away when you're just demoing use of Kubernetes. Okay, print the IP of that host. Copy it, and reference it to create a WebSocket from the terminal. We'll use websocat. Here comes the address. We're using this 30,010 node port for now, and the resource upgrading the connection to a WebSocket. Now, the query parameters for this WebSocket address are measure. We're measuring GDP, the date, country. We'll percent encode these spaces, and the region is California. Press Enter to create a WebSocket directly with the measure service in Kubernetes. Okay, the terminal WebSocket is listening. Now let's request a transaction and approve it to demonstrate a real-time increase in California GDP. Open our in-editor HTTP client. Select the env tab. Switch the HTTP client environment to dev so requests are sent to the dev GraphQL endpoint in Lambda. Switch to the Collections tab. Open the GraphQL collection. Then create request. And hit send. Little delay there because of the Lambda warm-up, but a transaction request was created with an ID of 7. Now open approve request and assign the ID query variable to an ID of 7. Okay, before hitting the approve request send button, we're looking down at this WebSocket connection in the terminal and waiting for a streamed California GDP value. So train your eyes here. Now hit send. Excellent. California's real-time GDP is 21.8. Let's approve another transaction. Create request send. Copy and reference ID. Then approve request send. Wonderful. California's new real-time GDP is 43.6. Okay. Postgres sends a GDP notification. An event service receives the GDP notification and increments a GDP key in Redis. Then Redis publishes the changed GDP value to a channel, and the measure service subscribes to the Redis channel and sends the value through a WebSocket. This all happens in a Kubernetes instance running in the cloud. In the next video, let's visualize the data managed by these new services so the public can get a glimpse of how an economy looks when it doesn't have democracy and committees and mass media and academia trying to overrule a natural physical law we all learned about in middle school. You may subscribe, share, and contribute from the buttons and links in the description.